So this is the remote desktop that you will be working on for the Simulation Plus software. So when you open it, it's like you're working on someone else's desktop. So you will find that you have here DDDPlus, which is drug dissolution and disintegration, admit predictor, multiple versions, GastroPlus, PKPLUS and PKPLUS tools, membrane and Medcom. We will work on DDDPlus and GastroPlus. So first of all, you copy the SDF or MOL file from your desktop to this remote desktop to make it easier for you. Okay, and then you go to DDDPlus, double click on that. So the first thing you see here is that you are working on demo file. So you can't change anything in this demo. So first of all, you have to go to File, Save, and save database as, and then you name it as you want. So I will name it and then save. Okay. So now we are not working on the demo anymore. We'll go to File, Import. You will see here that the software already has some drugs. So you can work on, but you can import the structure you want as long as you have it on in SDF or MOL file. So you'll go to File, Import, and Import Structure. So let's see, let's work on this. It's an SDF file, so open. And there is no need to change anything in this window, so you hit OK. And then it goes back to hydrocortisone, so you will click on this arrow and you choose the new structure, which is ASA CT. So you're now working on this molecule. The dosage form, you can change it. You have multiple options: tablet, capsule, bead coating. So let's choose tablet. You can change the tablet diameter, the compression force, disintegration time. So disintegration time is, if it's 0, it doesn't mean that it skips the disintegration step. It means that it predicts it from the structure of the formula, the structure of the molecule, and from the other parameters you put in the formulation. So other ingredients or the tablet diameter and everything else. But if you know the exact disintegration time of your drug, you can change it. Okay. So what we can change here is ingredient information. So you go to Edit Formulation, and you have here your drug, the chemical structure of it, molecular weight, solubility, density, log P. If you know that these things are slightly incorrect, you can change them. Then to add other excipients to the formulation, you can either add an ingredient, but you have to import the structure of it and enter the physiochemical parameters or physiochemical information of this new ingredient, or you can import excipients from the software itself. The software itself has many excipients. So you can see here we have multiple types. You can sort them according to the type. So you have disintegrants, polymers, solubilizers, wetting agents, with all their physiochemical properties. So, for example, let's choose one of these. Let's choose, for example, lactose. Okay, add excipient to formulation and then close. If you know that you are using lactose for something specific, you can change it from here. Solubilizer, wetting agent, disintegrant, or other. Or if you want to add more than one solubilizer or one disintegrant, it's okay. Here you have some physical chemical properties of the lactose and the amount. So you can change the amount from 10 milligram to 100 milligram, for example. I will change it to 100 milligram. You can change the mean radius size, the standard deviation. Also for the aspirin, the same thing. Mean radius and standard deviation, number of pens. Even you can change the dissolution model from mass transfer to this, but we will keep it on mass transfer for now. And you can import as many excipients as you want. So we'll hit close. This is the formulation we have. Okay, then we go to the dissolution method. So if you know you are using USP apparatus 1, you can change to basket, apparatus 2, paddle, and you have many different apparatus types. So let's say we are using the basket. We can change the medium type, different types of medium. Let's say I will use of course, for each molecule, there's specific dissolution USP model that you can use. But let's say, for example, we are using USP acetate 4.5. The protocol says that it's 500 milliliter, for example, and let's say 75 RPM as the speed, not 100. Here you have multiple options, so you can make sure that the composition of this medium type is correct. So you click on medium composition. So it's sodium acetate and acetic acid, and these are the concentrations of each. Dissolution phase, you want to mimic the dissolution in different parts of the body. So you can add phase 1 to mimic, for example, the stomach, and phase 2 to mimic, for example, the intestine. So you can add and change the type of medium, and here it gives you that the first phase will run from time 0 to 30 minutes. Phase 2 will run from time 30 minutes to 60 minutes. I will delete it for now, and then, okay. Here you have also some advanced option like biphasic settings. If you want to add organic solvent, you can add it. First you have to check this, turn on biphasic dissolution and change the volume, density, and other parameters of the organic solution. Here, if you want to study the dissolution with membrane flux, so you check this box and then you change the thickness, the area of the membranes, and etc. Then you go to simulation. You will make sure that you are working on your molecule from this. So keep these as use internal and use mean as predicted, the solubility calculation and PST calculation. The default simulation length time is 60 minutes. So let's try this. We hit start and it's complete. So you want to see your results, go to display graph, and that's it. Here is your dissolution. So you have multiple options here. First, when you point at any part of this curve, you will see you have X and Y right here. So you will point at this peak, you will see that at X equals 2.83, you will have Y as 100.1, for example. This is the percent dissolved versus time curve. You can display the amount dissolved versus time instead of percent. You can see the particle size distribution of both ingredients or one ingredient if you want. So you say we didn't change the particle size. It was at the radius was 25. So it gives you here that most of the particles are from 22 to 29 micrometer. Also, you can see pH versus time. So it gives you each ingredient, the pH of it. So you see lactose, medium, and aspirin. This is the excipient, and this is our active. And you can check and uncheck whatever you want. We will go back to percent dissolved. You can go here and edit your axis. So You go to axes, you can edit a lot of things, but for example, let's stay with the axes, you can make them automatic, you can change them, you can change the maximum, the bottom axis as well. And if you see that there is no need for 60, you can just close this and change this to, let's say, 20 minutes, start again, and you will see it's more visible right now. So you can see the maximum percent dissolved in a better way here. So to save this, first, you want to save this to solution. So you right click on this and export simulated data to GastroPlus, GSG file. So let's name it tutorial DDD results. It will be saved in DDDPlus folder. Okay, then you close this, and when you close this, it will give you like a warning window that you want to save these changes you have made to this database, so you will save them in order to work on them in the future. So yes, and now we are done with DDDPlus. Now to go to GastroPlus, there are multiple versions of GastroPlus, so we will work on the newest one. So this is GastroPlus 982. So the same thing as we did with DDDPlus. First of all, you have to change the database you're working on from demo to another one. So save data drug base and it will be saved in GastroPlus folder. Okay, so now we can start working on this. The same thing, file, import, and then import structure. So I've saved it on desktop. So this is my structure. Open. Here, you don't have to change multiple things except for one thing, which is this clearance. In order to get some half-life and clearance value, you have to change this from use predicted total liver microsome to use predicted all recombinant SIMs. Okay, and here you can also change the PK model you are working on. So do you want to work on compartmental or physiological based PK? So let's say we're working on the compartmental. These are ones that I have created, but I think the software itself has like a different PBPK. But let's stick with compartmental for now. And if you want to work on PBPK, you can create a new PBPK from here. You choose the type of species, so animals, humans, population, ethnicity, gender, health status, age, and weight, height, BMI, and all these things. For me, I will stay with compartmental, and as I said, use predicted all recombinant SIPs, and hit OK. Just like we did with DDDPlus, you will want to make sure that you are working on your molecule, so you choose it again from here. So this is our structure. Same dosage form. We want to make sure that we are working on the same dosage form as we worked on DDDPlus and the same dose. Here, if you want to make it one dose only, you keep it like this. If you want to make it multiple dosing, you can add subsequent dosing, the dosing interval in hours, and the this is relates to the volume of water that the person drinks with the drug. So it's by default 250 milliliter. Here, if you have other information about your drug, you can change them regarding to the permeability, diffusion coefficient, and at the bottom here, you will see that some parameters or properties that were predicted from ADMET Predictor, which is another software. Tendency supersaturate, blood-brain barrier penetration, ECCS classification, And even if you go even further, you can see binding to plasma, to some transporters, OCT transport inhibitor, no. And it's 99% that it's not an OCT2 inhibitor. 87% that it is an OAT1 inhibitor, and all these kind of things. So you'll see here the different kinds of CYPs and transporters. Nothing to change really here. We'll go to the next tab, which is gut physiology in human. Here you see that they have divided the gastrointestinal tract to 9 compartments, which is complex, but nothing to change actually here. We'll go to pharmacokinetics. So here you see that it's compartmental as we have chosen. The same thing, if you want to create a new PBPK, just click on here and add. So compartmental, you can change even the body weight. So it gave us already some parameters relating to the fraction unbound in plasma, which is 10.17%, total clearance 0.18 liter per hour, volume of distribution in central compartment 0.23, and half-life 62 hours. So apparently, because there are no values here and here, it's dealing with it as its one compartment model. So we have only one volume of distribution, and we don't have anything in these relating to the second compartment and third compartment, if any. Here, if you have some observed values about the drug you're working on from like in vitro experiments or previous experiments, you can plug them here. So if you know that the Cmax of your drug is some in some species, for example, or you just want to simulate your results to see if they are correlating, you know, the availability, the area under the curve, hepatic clearance. If you don't know them, it's okay, you can keep them as it is. And then you go to simulation. So we have here multiple simulation modes. So we will work on single simulation, but you can work on population simulator, batch simulation, and parameter sensitivity analysis. So these are more complicated. For now, we will work on single simulation. The default length for simulation is 24 hours. You can change them to 48 hours, 96 hours. And then you go to start. Okay, so we will have here calculated values for the this drug. So you see here fraction absorbed in intestine 98.8, fraction accumulated in cumulative fraction absorbed into portal vein 98, absolute per oral availability, Cmax, Tmax, area under the curve from 0 to infinity and from 0 to T, and Cmax. To see the curve, you go to graph, and this is your curve on Cartesian curve. So if you want to see it on semi-log, you go to here, and this is on semi-log graph. So the same thing as we did in DDDPlus, you point your arrow at any place you want and it gives you the X and Y. So you see here, X is 1.4 and Y is 5.7. So at 1.4 hours, the concentration was 5.7. If you remember from simulation tab, we had the Tmax is 2 and Cmax is 5.8. So you can make sure Tmax is 2 and Cmax was 5. Yes. Okay. Here we have multiple options. So you can see also the absorption and dissolution for the drug. So here amount dissoluted and amount absorbed. So you can untick these and see how the absorption and dissolution are relating to each other. So this is the dissolution and this is the absorption. Here you can see regional absorption, so where the drug is being absorbed. So 98.8% of the drug is absorbed, 56.3 of it is absorbed in the duodenum, 32.2 in the jejunum, and the rest of it is in different parts of the gastrointestinal tract. So we'll go back to the CP versus time, and we will go to the semi-log. And to save this graph, and you can do the same in DDDPlus, you can just right-click and copy image to clipboard, and then you go to, for example, Paint in your desktop and just paste it, and that's it. You get the curve in your desktop. To get the parameters you had here, these ones, you go to Graph and save selected data. Include model parameters and save file. So it will be saved as a text file. So let's see. And save. Okay. So to see your results, just go to here and recent places, then GastroPlus 9.82, and this is our results. So here you see immediate release, tablet dose, subsequent dosing, dosing interval, and the dose volume, which is 250 milliliter, if you remember. Here are different length, volumes, radius, transit times of different parts of the gastrointestinal tract. These are the physicochemical properties of our molecule, pK values, solubility and dissolution, model options, and all these. Okay, so now to see when we want to combine what we have done in DDDPlus compared to GastroPlus, these simulations were for the file as it is, without the dissolution results we got from DDDPlus. So in order to get that, the same thing, we are still working in our compound. Just go to File and then Load. So the previous one, which I did, you don't need to do it. I was just showing you how does it look like to work on GastroPlus. But if you want to get the results of what you have done from DDDPlus to put them in GastroPlus, you go to Load and load the in vitro dissolution release versus time profile. So File, Open. And then we have saved it, as you remember, in DDDPlus. So we'll go to DDDPlus. And then, let's see, it was this. Tutorial DDD results open. On File, Save As. We'll keep it as it is, so save. And then, okay. So you will see here that the support files have our results from DDDPlus. Previously, there was nothing in this section, support file, but now, because we have loaded our results from DDDPlus, we are combining the dissolution results from the results that GastroPlus will give us. We will keep the same thing, and we will hit simulation again, and then go to graph. So let's see. Now, some excipients will for sure change the curve you're seeing originally from aspirin alone but some of them will not have this major effect. So for example, the excipient that we have chosen, you see that it didn't change actually the PK parameters we had here, neither as values or as a curve of the CP versus time. But if you change some excipients or add them in certain values, you will see some changes in the simulation results. So as we did earlier, you can copy image to clipboard and paste it on Paint, and then you can save selected data, include model parameters, save file. So I will call it this time GastroPlus DDD results. And that's it. So the first step I have done is to show you the pharmacokinetics and simulation of the molecule alone. Then I went back to compound, then file, load, as I said, and load DST file, which is dissolution, in vitro dissolution release versus time profile. So you will see that when you load different dissolution versus release versus time profiles, you will have different simulation results. But the original compound as it is without any support file, it will have the same simulation results and the same graph, as long as you are keeping the same initial dose and the same dosage form and the same subsequent doses or dosing interval. And that's it. Same as we did in DDDPlus. When you close it, it will it should give you the warning sign that if you want to keep changes permanently on working database, so you just click OK, and that's it. To log off of this remote desktop, the proper way is to double click on this, log off, and that's it. I hope everything is clear. If you have any question regarding working on DDDPlus or GastroPlus, just let me know, and thank you for watching this tutorial.